If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see an example on sinusoidal steady state analysis, nodal analysis. Question: use nodal analysis to find VO in the circuit of figure. Let omega is equal to 2 kiloradian per second. So here for this circuit, we have to find the value of this VO by using nodal analysis. Solution: first of all, we will take this circuit. Now as we can see, this circuit is currently given in time domain format. So we will convert this into its equivalent phasor domain format. Convert time domain into phasor domain or frequency domain. Convert time domain into phasor domain. So here we can see this is 36 sin omega t ampere. So first of all, we need to change this into standard form. So in standard format, it will be 36 cos omega t minus 90 degree ampere. Now the value of omega is given. Omega is equal to 2 kiloradian per second. Omega is equal to 2 kiloradian per second. So this will be 36 cos 2000. In place of omega, we can substitute this 2000 t minus 90 degree ampere. So this is in time domain. In phasor domain, this will be 36 at an angle minus 90 degree ampere. Then next, this 2 kilo ohm will remain same. This small Vx will change to capital Vx. Then this 50 millihenry will change to j omega L. So j into omega value is 2000. So 2000 multiplied with inductance value is 50 into 10 to the power minus 3. So let's solve this. J into 2000 multiplied with 50 multiplied with 10 to the power minus 3. So 100 J ohm. Then this 2 microfarad. Will change to 1 upon j omega c. So 1 upon j into omega value is 2000 into capacitance value is 2 into 10 to the power minus 6. It is equal to 1 upon j into 2000 into 2 into 10 to the power minus 6 minus 250 j ohm. Then this 4 kilo ohm will remain same and this 0.1 Vx will change to capital Vx. Also this small Vo will change to capital Vo. Small Vo will change to capital Vo. Now here we can replace all these values. So this 36 sin omega t will change to 36 cos omega t minus 90 degree, and this is in time domain. In phasor domain, this will be 36 at an angle minus 90 degree. So 36 at an angle minus 90 degree ampere. Then this 50 millihenry will change to 100 J ohm. 50 millihenry will change to 100 J ohm. 2 microfarad will change to minus 250 J ohm. Minus 250 J ohm. This small Vx will change to capital Vx. Also this small Vx will change to capital Vx. This small Vo will change to capital Vo. So now here we can assume this as the reference, this as the node 1 V1, and this as the reference node, and this as the node V2, or we can take this as VO node because here the voltage is VO. So let's take this node as VO and this node as V1. Now let's assume this current is current I1, this current is current I2, this current is current I3, and this current is current I4. Now let's apply KCL at node V1. So let's apply KCL at node V1. Now according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node entering current is 36 at an angle 90 degree minus 90 degree, 36 at an angle minus 90 degree. Now it is equal to leaving current. Leaving current is I1, I2 and I3. I1 plus I2 plus I3. 36 at an angle minus 90 degree is equal to, now this I1 is equal to, here we can see I1 is equal to V1 minus 0 divided by 2000. V1 minus 0 divided by 2000 plus I2. Now this I2 is V1 minus 0 divided by 100J. V1 minus 0 divided by 100J plus I3. So I3 is V1 minus VO. V1 minus VO divided by minus 250J. Minus 250J. Now let's simplify this. So it will be 36 at an angle minus 90 degree is equal to, we can take this V1 common. So V1 in bracket 1 upon 2000 plus 1 upon 100J, then plus 1 upon minus 250J. Bracket close, then plus VO in bracket minus 1 upon minus 250J. So 36 at an angle minus 90 degree is equal to V1 in bracket, let's solve this, 1 upon 2000 plus 1 upon 100 into J, then plus 1 upon minus 250 into J. So it is equal to 5 into 10 to the power minus 4. 5 into 10 to the power minus 4 minus 6 into 10 to the power minus 6 into 10 to the power minus 3 J plus VO. Now this will be minus 1 divided by minus 250 into J. So it is minus 4 into 10 to the power minus 3 J. Minus 4 into 10 to the power minus 3 into J. Now let's assume this as equation number 1. Next we will apply KCL at node VO. So apply KCL at node VO. Now according to Kirchhoff's current law, again summation of I in is equal to summation of I out. Now here at this node entering current is I3. Only I3 is the entering current. So I3 is equal to leaving current is, here we can see leaving current is 0.1 Vx. 0.1 Vx. Then I4. I4 is also leaving current. So plus I4. Now we can write this I3 in voltage form. So it will be V1 minus VO divided by minus 250J. V1 minus VO divided by minus 250J. It is equal to 0.1 into Vx. Now this Vx is this current I2 multiplied with 100J. Here we can write Vx is equal to current into resistance. So current is I2 multiplied with 100J. Current into impedance. So impedance is 100J. And I2 is equal to V1, or simply here we can see Vx is simply equal to V1. Here we can write Vx is equal to simply V1. So it will be V1 plus now I4. So I4 is VO minus 0 divided by 4000. VO minus 0 divided by 4000. Now let's simplify this. So it will be V1 divided by minus 250. V1 divided by minus 250J minus VO divided by minus 250J. Now if we take this on left side, so it will be minus 0.1 V1 minus VO divided by 4000 is equal to 0. So V1 in bracket 1 upon minus 250, 1 upon minus 250J and minus 0.1 plus VO in bracket minus 1 upon minus 250J, then minus 1 upon 4000, and it is equal to 0. So let's simplify this. V1 in bracket 1 upon 250 into J minus 0.1. So it is minus 0.1 minus 4 into 10 to the power minus 3 J plus VO in bracket minus 1 upon minus 250 into J minus 1 upon 4000. So minus 2.5 into 10 to the power minus 4 minus 2.5 into 10 to the power minus 4 minus 4 into 10 to the power minus 3 j is equal to 0. Now this is equation number 2. Now we will solve this by using matrix method. Solve equation 1 and 2. So here we will put this in matrix form. So from equation number 1, V1 term is this. Let's take it from here. Then from equation number 2, it is this. Then from equation 1, VO term is this. From equation 2, VO term is this. And here this will be V1 and VO. These are the two unknowns we have to find. And it is equal to, from equation 1, it is equal to 36 at an angle minus 90 degree. 36 at an angle minus 90 degree. And from equation 2, it is equal to 0. Now first of all, we have to find the value of delta. So to find the value of delta, we have to take the determinant of this matrix. So let's take this matrix from here. Now we have to take this, we have to take its determinant. So this into this, 5 into 10 to the power minus 4 minus 6 into 10 to the power minus 3 j multiplied with this term 2.5. Let's copy it from here. Then minus this into this. Let's copy it. Then multiply with this. So delta is equal to 5 into 10 to the power minus 4, 5 into 10 to the power minus 4, then minus 6 into 10 to the power minus 3 into j, then multiplied with minus 2.5 into 10 to the power minus 4 minus 4 into 10 to the power minus 3 into j, then minus in bracket minus 0.1 minus 4 into 10 to the power minus 3 into j, bracket close, into minus 4 into 10 to the power minus 3 into j. So it is equal to this much in rectangular form. In polar form, this will be shift 2, 3. So 4 into 10 to the power minus 4 4 into 10 to the power minus 4 at an angle minus 91.16 degree. So now we got the value of delta. Next we have to find the value of delta 1. So again for delta 1 we have to take this determinant, but here this time we have to replace first column of this determinant. We have to replace this first column by 36 at an angle minus 90 degree and 0. 36 at an angle minus 90 degree and 0. So delta 1 will be equal to this into this. 36 at an angle minus 90 degree multiplied with this term. Let's copy it from here. Minus 0. So 36 at an angle minus 90 degree multiplied with minus 2.5 into 10 to the power minus 4 minus 4 into 10 to the power minus 3 into j. So it is equal to this much, minus 0.144 plus 9 into 10 to the power minus 3 minus 0.144 plus 9 into 10 to the power minus 3 j. This is the value of delta 1. Then next we have to find the value of delta 2. So for delta 2, again we have to take this matrix. We have to take this determinant, and now this time we have to replace this second column. We have to replace this second column by 36 at an angle minus 90 degree and 0. 36 at an angle minus 90 degree and 0. So this into this, it will be 0. Then minus this into this. So 36 at an angle minus 90 degree multiplied with minus 0.1 minus 4 into 10 to the power minus 3 j. So it is equal to delta 2. Minus 36 at an angle minus 90 degree multiplied with minus 0.1 minus 4 into 10 to the power minus 3 into j, bracket close. It is equal to 0.144 minus 3.6 j. So now we got delta 1 and delta 2. So we can find the value of V1 and VO. So V1 is equal to delta 1 upon delta. So delta 1 value is this much. Let's copy it from here. This is the value of delta 1, and the value of delta is, this is the value of delta. We can take these values in either polar form or in rectangular form. So if we simplify this, then V1 is equal to minus 0.144 plus 9 into 10 to the power minus 3 into j. divided by 4 into 10 to the power minus 4 at an angle minus 91.16. Shift to 3. So it is 360.70 at an angle 360.70 at an angle minus 92.4 minus 92.41 degree volt. So this is the answer for V1. Then for V2, V2 is equal to delta 2 divided by delta. Now the value of delta 2 is this value. This is the value of delta 2 divided by delta value is, this is the value of delta. So V2 is equal to this upon this, 0.144 minus 3.6 into J divided by 4 into 10 to the power minus 4 at an angle minus 91.16. So it is equal to this much in rectangular form. In polar form, this will be shift to 3. So it is 9007.19 at an angle 3.45 degree volt. So this is the answer for V2. Let's verify again. 0.144 minus 3.6 into J divided by 4 into 10 to the power minus 4 at an angle minus 91.16. So it is this much. Shift to 3. So it is correct. Now next, here what we have to find, and this is, here we can see this is not V2, it is, here we can see it is V1 and VO. So this is not V2, this is VO. Let's correct it. So this is VO. Here also this is VO. Now in this problem, what we have to find? Use nodal analysis to find VO in the circuit of figure. So we have to find the value of VO. Now we got the value of VO in phasor domain. In time domain, this will be V is equal to Vm cos omega t plus phi. So small VO is equal to Vm value is 9007.19 cos omega value is, here we can see the value of omega is 2000 radian per second. 2000 t plus phi value is 3.45 degree, and since it is a voltage, so its unit will be volts. So this is the value of VO in time domain format, and this is how we can find VO by using nodal analysis. Don't forget to check out the other videos on this channel, and thanks for watching.